Hello, everyone, and welcome to the second day of CloudNXT 2022, Globant's premier web conference on cloud and DevOps. Hope you all had some good pointers to take back home yesterday, and we'll make sure that you are going to have a great time today as well.
Our next presentation is about chaos engineering. Chaos engineering is a practice that implements the best state of the art techniques on your architecture to improve resiliency, reliability, and find issues before they find you.
And now, let me introduce our speaker for this talk, who is an IT enthusiast with over 12 years of experience, Mauro Boffito, working at Globant as a senior DevOps engineer and helping improve chaos practice within the studio. Mauro loves working with new technologies and facing constant challenges. Welcome, Mauro.
Hello everyone, I'm Mauro Boffito. I'm part of the chaos engineering practice that's being currently developed under the Cloud Ops Studio. Today I'm going to be giving you a brief introduction of what is chaos engineering here at Globant. So as I mentioned, chaos engineering is a new practice that we have onboarded into the Cloud Ops Studio. So we're going to be talking about it. Today's agenda, we're going to be talking about what is actually not chaos engineering. That's a common social misunderstanding. We're going to be talking about definitions, benefits of it, what's happening in the market about it, how we are going to practice it on Globant, our tech stack, a quick demo video, and the final thoughts. So where is chaos? We will start talking about what is not and what is chaos to break some common myths. So where is not chaos? Chaos is not breaking things on purpose. Chaos is not testing on production. Chaos is not only for large and modern companies. Chaos can be applied to any scale company with any grade of maturity. Chaos engineering is only for very mature team products. That's not true at all. And finally, what is not chaos is only for complex architecture design. That's also not true. Chaos can be applied on any kind of architectural design and wherever we want to. Now we're going to be talking about where is actually chaos. Chaos is running experiments to get knowledge of our complex systems, to get knowledge of our architectures and how our microservices interact with each other. Chaos engineering is about following a scientific method, a practice to get our hypothesis for planning strategies to test your system performance against different scenarios. Chaos is getting your team in sync on possible performance issues on your infrastructure. It's getting your teams to work with each other to perform better. What is chaos engineering? Chaos engineering is about finding problems in your system before they actually find you. It's about injecting a controlled and well-understood failure into your system. It's about using that output we got from injecting that controlled chaos to create a self-healing system to prevent future issues with our applications. So, where is chaos at Globant? Here is our definition and the benefits we find of it. This is how we practice chaos at Globant. So, chaos engineering is responsible for implementing the best state-of-the-art techniques and practices to create, build, and assure what we call the elite patterns. Those are scalability, reliability, availability, and quality for your products, applications, and services. Our approach focuses on helping you predict issues rather than fixing incidents from network and application outages. Here, we can see chaos engineering giving us some benefits like identifying and making test integration and potential failures, improving the IT fitness by creating runbooks, building trust in our systems, as well as also trust between teams and our teams. It also helps expose technical depth. It enables experiment-based learnings, and it delivers improved reliability and resiliency of the system to reduce downtime. Chaos engineering is a practice relatively new to the market. It probably began about 2 or 3 years ago, but it's rapidly getting strength. And by so, it's expected that 40% of organizations will be implementing chaos engineering by 2023. as part of their DevOps initiatives. So, chaos engineering. These are the three main areas where chaos engineers can provide value for your organization. It has a customer section, a technical, and a business one. In the customer section, it helps improve the availability and durability of the systems and reducing the outages and reputational damages. On the technical side, we can help reduce the incidents and help boost our DevOps team understanding the system failures. On the business side, it has several benefits. It will not only help gain better reputational knowledge of us, but it will also help our teams be better prepared to face challenges and be better prepared to communicate with each other whenever they face a new outage or a challenge coming. How are we going to practice chaos engineering at Globant? Well, there are three dimensions where chaos engineering fits in Globant. We have what we call the standalone experiments. This is just a manual process of running chaos experiments that will help generate new knowledge about the system, and you will be able to generate a new hypothesis around it. Another dimension is what we call continuous chaos. This is using chaos and DevOps to generate a new loop regarding the standalone experiment and the final self-healing system. So every time you will overcome an issue or a weakness with a chaos experiment, it's time to integrate that chaos experiment to a test, to a DevOps cycle, and create new stages in our core to deliver and avoid them happening in the future. Finally, we have what we call the game days. Game days will not only help improve the IT stack or our complex architectural design by showing their flaws, but will also help practice between the teams. It will help understand how the teams relate to each other and how they will face real world situations. Our tech stack here at Globant, our chaos engineering tech stack, it's composed by Gremlin, Chaos Mesh, Azure Chaos Studio, Litmus, Chaos Toolkit, among others. We are currently partnering with Gremlin on this practice, and it's fundamental to understand that it's needed a good observability stack to help deploy and develop chaos engineering. So here, let me show you a quick sample of what continuous chaos looks like. Here on this diagram, you will see that we are integrating a Gremlin chaos engineering stack together with Jenkins, with ticket tracking in Jira, inside a cluster that it's all monitored by our observability stack. The example, it's a latency injection on a web service. So the idea of this attack will be monitoring how our services responds to injecting latency into them. So let me share you. So in this experiment, we'll be setting up a Jenkins pipeline with Gremlin and Jira integration. We'll be testing latency attack scenarios to the client via Jenkins automated pipeline to determine if custom settings are enough to support a web service running. This scenario will be monitored via Datadog, and we will be updating our job traceability in Jira via Jenkins. This is the stack I was talking to you about a couple of moments ago. And here's what we call our scientific method. What we will be observing is the standard configuration of a virtual machine. There are questions will be if this website will be available if we increase the latency. Our hypothesis is that the website will have too much latency that it will make navigation and user experience difficult. How are we going to be doing this is via the experiment. We'll be using Gremlin latency attack in coordination with Datadog to monitor the health of the system. So this is what the scenario looks like. The scenario consists of a health check that is always running. It runs every 10 seconds, and the different stages of latency attacks. So we will be increasing the latency attacks as the time goes by, and we will see if the health check keeps on having a green status or it fails. So this is how our pipeline of Jenkins work looks like. We are launching our attacks and experiments. Let's check on the Jira. Jira got updated with the scenario link. Now we are moving to the Gremlin console. Here on the Gremlin console, we can see the scenario we have set up. The Apache status health, as you can see, it's checking for status code 200, and it will time out if the request goes above 2000. The first attack has been running, injecting 500 milliseconds latency onto the service. We can monitor all of this in our observability stacks. Those bars, red bars, represent every start and stop of attacks. This helps us understand if our situation and our metrics are actually showing an attack or are actually showing real world situations. We can see that also it will source all of the Gremlin's attacks thanks to its integrations with Gremlin. Getting back to the scenario, we can see that our hypothesis failed, and it went over the 2000 milliseconds for our web response, making the site user not friendly. So the final thought is that this custom setup of the clusters was not enough for our website to process the high amounts of data requests. Our company should adopt a new measure such as scalability or an application load balancing to avoid these events. It's recommended to run these scenarios on a monthly basis to understand the current and incremental load of them. So I really appreciate your time. Thanks for it.
Thank you, Mauro.
So our next session is about the capabilities of Spinnaker as a continuous delivery tool and how to utilize Spinnaker to implement immutable infrastructure while adhering to compliance requirements like FedRAMP.
Darshan Patil, who is a DevOps technical architect at Globant. He has extensive experience in setting up and managing infrastructure and implementing DevOps automations on a wide range of AWS cloud solution architectures. He loves to deep dive into the application and infrastructure architectures to drive performance, scale operational efficiency. Handing over to Darshan.
Hi everyone, this is Darshan Patil here. I am the technical architect, DevOps technical architect in Globant. Today we'll go through the Spinnaker details. So we will see how to implement immutable infrastructure, compliance, and continuous delivery using Spinnaker. So agenda for today is, so we will see what is Spinnaker. We will go through its history, what is Spinnaker, why we use Spinnaker, and what are the details you need to take care when you're migrating to Spinnaker, and then how to do application management using Spinnaker, choosing your deployment strategies, how Spinnaker helps in achieving compliances like the FedRAMP compliance, how can you achieve immutable infrastructure deployment on AWS cloud, and then we will have a look of what is happening inside Spinnaker. So, do you binge watch Netflix? Do you love this seamless experience? So many of you have most of the time have observed that when you are streaming your favorite content, so you are having that seamless experience. So what is behind that Netflix? Behind the Netflix, there is a powerful CD tool that is Spinnaker. Okay, so let's discuss about Spinnaker. What is Spinnaker and its history? So Spinnaker is an open source tool, multi-cloud continuous delivery application, which helps you to release your software updates and deploy your software changes to the production quickly, safely, and automatically. So Spinnaker was born in 2015 from the Netflix, and then so initially it was developed by Netflix, and then it was developed by Google, and now as of now it is supported by multiple vendors like OpsMX and Armory. So these vendors can help you set up the Spinnaker, provide the support to the backend issues, and everything. Okay. Yeah. Now, why should we use Spinnaker? Okay. So Spinnaker have lots of inbuilt functionalities, which makes it as a powerful CD tool. So Spinnaker is compatible with major cloud providers like AWS, Google Cloud, Azure, Kubernetes as well. So Spinnaker can be used for application management and application deployment. So when we say application management, so you have a Spinnaker GUI wherein you could see all your server groups, your instances, and the complete pipeline with all the stages. So from the Spinnaker GUI itself, you can do a lot of application management. You can launch new server groups. You can terminate it. You can spin up new pipelines and all. So most often you don't even need to log into your cloud console uh, to do those management. And of course, the application deployment is also provided by Spinnaker. Spinnaker have integration with lots of CI tools like Jenkins and Travis CI. Then you can you can save your Spinnaker pipeline as a code. So you can save a JSON file which has the complete code of your Spinnaker pipeline. So it's a declarative approach you'll be following. You always know what will be your end pipeline, how your end pipeline will look like, what will be the functionalities and all. Then Spinnaker integrates with a lot of tools like HashiCorp tools like HashiCorp Terraform, HashiCorp Vault, so that you can automate your infrastructure. You can deploy your infrastructure through Spinnaker, and even you can have that secrets management using Vault. You can trigger Spinnaker pipeline using Git repo, cron jobs, and the other Spinnaker pipeline stages. You can switch from multiple releases per week or per month to multiple releases per day. So it's so using Spinnaker you can have you can have quick releases, and you can have frequent deployments. So you can deploy multiple times a day. Spinnaker integrates with your accounts using the role-based access control. Okay, it's a role-based integration, so it's safe and secure. Then Spinnaker integrates with monitoring services like Prometheus, Datadog, New Relic, SignalFX, Stackdriver. You can also have email alerts or Slack alerts, HIP chats, or SMS events from the Spinnaker. So as soon as one of the stage has finished, or Spinnaker pipeline has finished, you can always have that stage to trigger the notifications for you. You can utilize, so Spinnaker helps you to utilize the manual approval process. So if you're deploying your application from one environment to the other environment, like you're going from stage to prod, you can have that manual judgment step anytime in your Spinnaker pipeline. You can in Spinnaker you can also do the post deployment testing. So once your application is deployed, you can have a stage wherein you will run some of the test cases against your deployed environment and decide whether the deployed environment is perfectly working fine or not, and then take a decision on the rollbacks. Spinnaker, so when baking using Spinnaker, so Spinnaker uses Packer or the VM image bakery tool to bake all your artifacts or application in the AMI. Yeah. Now, if you are already using some of the CD tool, or if you're trying to set up a CI/CD pipeline for your application, you can try to switch to Spinnaker. Okay. So if you need quicker time to market, you want frequent deployments, quicker releases, quicker time to market, you can utilize Spinnaker. If you want to leverage multi-cloud deployments and multi-region deployments within Spinnaker pipeline, so you can use Spinnaker. If you want immutable deployments of infra and an application in a single pipeline, so there will be a single Spinnaker pipeline wherein you will be first baking your image, you will be deploying your infrastructure, and then you will be deploying your application on top of that infrastructure. So it's if you need a declarative approach, for example, you will be preparing a pipeline as a code, or you will be defining your complete artifacts well ahead. So you always know what will be my end pipeline, how it will look like, and how it will behave. You can deploy multiple times a day. You can manage compliances using Spinnaker. So compliances like FedRAMP, PCI DSS, SOC 2. Yeah. So we'll talk about how we can manage FedRAMP compliance using Spinnaker in our further slides. Spinnaker, if you want to reduce bad deployments, issues, and outages, then you can consider to migrate to Spinnaker. If you want to quicker disaster recovery setup, so with simple changes like just modifying some of the variables, you can quickly deploy it to some another region, or you can easily replicate your Spinnaker pipeline in your application. If you want a safe and reliable way to patch your servers, if you want frequent patching to be done with regards to the compliance, Spinnaker helps you to achieve that. Templated pipelines. So you can always template your Spinnaker pipeline. You can utilize one pipeline template to create another pipeline template. Faster rollbacks. So within few clicks. So if you when you're doing the application management using Spinnaker from the Spinnaker GUI itself, you can within few clicks you can roll back your application to the earlier versions. You can easily solve the drift issues because Spinnaker GUI will always be providing you all those complete holistic view of your application deployments, infrastructure deployments, and the bakings into a single pipeline. Also, if you want to, if your organization wants that every team in the organization should follow same approach or the same process, and everyone should adhere to the same process, then you can utilize Spinnaker to enforce all those org level approaches in your organization. Yeah. Now, application management using Spinnaker. Okay. So this is a Spinnaker GUI console. Okay. I just have my pointer to explain you. So on the left hand side, you can see pipelines. So if you click on the pipelines, you will get the complete list of what all pipelines you have implemented under your project in Spinnaker. Then you have the clusters option. So cluster is nothing but a collection of server groups. You can see here we have 3 server groups, 84, 83, 82. And each server group is nothing but an autoscaling group from the AWS point of view. Okay. So in that autoscaling group or in that server group, you can see instances. So green, that means there's one instance which is completely healthy. If you click on the server group, you can see the server group information. That is the autoscaling group information. Like what is the VPC, what is the subnet, then what is the capacity, min max of that autoscaling group, health of these instances, launch configuration details, firewalls. Firewalls are nothing but the security groups, scaling policies, scaling processes. So all these details are clearly visible to you in this Spinnaker GUI. So this is the application management. So you can even click on create server group, and you can create additional server groups here. And in case of any issues, if you want to roll back your application, you can simply click on server group actions, and then in the drop down you can click on rollback, and within few clicks you will be able to roll back your application from 84 to 83 or 82, whatever you need. Okay. So indirectly, so Spinnaker helps you to manage your application right from the GUI. Okay. So most often you don't need to even log into the Cloud Console. So you can simply go here and do all the management. Yeah. Next, choose your deployment strategies. So Spinnaker supports a lot of different deployment strategies like red black, rolling red black, and the canary. So in the um, red black deployment strategy. So red black is nothing but the blue green deployment strategy. So Spinnaker calls it as a red black. So here, a new version of your application will be deployed onto the green environment, and you will immediately, once it is deployed, you will immediately cut over from the blue environment to the green environment. So in the rolling red black, when your application is when the new version of your application is deployed onto the green environment, slowly the traffic is being moved from blue environment to the green environment, and then the cutover is done. And in the canary deployments, when you deploy your new version of application on the green environment, you so basically the metrics of the green environment are evaluated against the metrics of the blue environment uh, using the baseline. And once it is confirmed that the green environment is perfectly working fine with no issues, then you do the cutover. So most often we often the best way to utilize Spinnaker deployment strategy is to have canary-based deployments that ensure that you even if there is any issues with the applications, you are less now, so the impact will be less, and it will be easy for you to roll back. Now, how can you achieve the compliances? So let's take an example of the FedRAMP compliance using Spinnaker. So the FedRAMP compliance, so on the left-hand side, you can see the requirements of a FedRAMP compliance, what are things are required. So Spinnaker have the functionalities to help achieve all these tasks on the FedRAMP compliance point of view. So you can, so FedRAMP requires that you should perform monthly patching of your servers. Okay, you should keep your servers up to date monthly. So without a powerful CD tool, it will be difficult for the team to manage the patching. Generally, for a team, it takes 2 to 3 days or 4 to 5 days to patch the servers. But that won't be the case with Spinnaker. So if you're utilizing Spinnaker, you can always have it will be easier for you to have monthly patching, especially when you're baking your AMIs within Spinnaker. So we will discuss on more details on how to achieve this monthly patching in the further slides. FedRAMP requires that your access to production should be protected. There should not be an unauthorized access to production. The Spinnaker uses role-based access control to protect your application in production. FedRAMP requires that an org level policies should be enforced so that none of the teams are deflecting or diverting from the FedRAMP process. Okay, So that's the best way to ensure that all your teams, especially in the big organizations, it becomes difficult uh, to maintain everything within the organization policies. So it's better to have Spinnaker to enforce all those org level policies in software development life cycle. Then using Spinnaker, you can have easy disaster recovery automation. Okay, within by changing few of the variables, you can easily set up a DR. If FairTime requires that, you should be able to scan your environment or scan your images, okay, well ahead before it goes live. Okay, so Spinnaker have that functionality. In Spinnaker, you can have a stage where you can run the scan on your images, or you can run the scan on your scan or test on your application, and before go live or before cut over, you can always take a decision on whether I need to go live or not. An end-to-end audit trail and change analysis could be done using Spinnaker. So on the Spinnaker GUI, you get to see all the details along with the logs. A single pipeline will be showcasing your infrastructure deployment, your application deployment, your baking. So it becomes easy for to gather all those audit proofs or the change analysis details from the Spinnaker. So we'll talk more about how can we achieve, about what should be our pipeline for the FedRAMP. Yeah, so now immutable infrastructure deployment on AWS Cloud. How can we have immutable infrastructure deployments? So you have a DevOps engineer, a developer who will commit the application code in the Git repo. Once it is in Git repo, Jenkins CI build will run. It will build your application and zip it and store it in some artifactory. So it could be anything. So I'm choosing artifactory here. Okay. Then you have a set of DevOps engineers who will prepare all those bootstrap scripts for your servers and applications. They'll prepare the bake scripts like installing some of the baseline packages for your application. Then the Terraform variables for your infrastructure deployment or infrastructure provisioning. And then the pipeline definition YAML. So pipeline definition YAML is nothing but when you want to create a Spinnaker pipeline, you want to create a JSON or a code of your Spinnaker pipeline, you need some variables or some parameters. So in this pipeline definition YAML file, you will be defining all those parameters required for provisioning or configuring your Spinnaker pipeline. So once it is in Git repo, a Jenkins CI will run, and when the Jenkins build is happening, there will be a set of scripts which will be running against your Bootstrap or the big script, whatever scripts you have in the Git repo. So what are those backend scripts which are doing that validation part? For that, let's go here. So you have a backend process team which will write all those validation scripts required for your Jenkins. So those validation scripts will validate your DevOps team's scripts, whether those are in correct format or not, whether those scripts or the YAML files adhere to the organization level policies or not. Okay, this is like a firewall or the validation. Okay, wherein a backend process team is ensuring that the other team, the DevOps engineer team, is adhering to the organization level policies and is well within the prescribed limits of provisioning the pipeline. Okay. So once the validation scripts are run, and so those scripts also prepare the Spinnaker pipeline JSON. Okay. Yeah. So once the Spinnaker pipeline JSON is prepared and the validation is done, everything is passed, then that artifact is stored in the artifactory. Then Jenkins triggers the Spinnaker, and the Spinnaker will pick all those artifacts, like the application code artifact and also the Spinnaker JSON file and the bootstrap or bake scripts artifact from the artifact tree. And then it will perform all those baking and infrastructure provisioning and the application deployment onto your environments accounts. So it will first deploy on the dev account, and then it will move ahead and deploy on the stage account and then the prod account. So any number of accounts. So here I have mentioned dev, stage, and prod. Okay. So we will see what exactly is happening inside Spinnaker. Okay, we'll get into the details. So before that, so you have a security team. So this is regarding the monthly patching, how we could ensure that monthly patching is being done and in a safe and secure way. So you have a security team who will be releasing the hardened patch AMIs each month. So security team will be taking care uh, of the backend AMIs. They will ensure that each month they are releasing an AMI with zero vulnerabilities or the reduced vulnerabilities and a hardened one. Okay, and these AMIs will be used by the Spinnaker pipeline. Okay, during the bake stage. Now let's go to the next slide. See here, what's happening inside Spinnaker. So let's have a look. So let's see how you can utilize Spinnaker, what stages you can have in order to have those bakings, infrastructure, immutable infrastructure, enforcing the organization level policies, FedRAMP compliances, and all. So here you could have so initial stages will be like the configuration, the info stage, wherein you will be collecting the details of artifacts, what artifacts are being pulled from the artifact tree, what is the Jenkins job against the Spinnaker run, so that it will be helpful for you during the audit process to mention what is being getting deployed as part of the Spinnaker pipeline. Then a final AMS stage wherein Spinnaker will search for the latest security released hardened AMI. So this will ensure that when you're running the Spinnaker pipeline, it will always pick the latest hardened AMI from the backend. Okay. And on top of it, baking will happen on the bake stage, wherein your AMI will be baked against the bake scripts which a developer engineer have committed here. Okay, so this baking and finding AMI is being happening in the source account, which is being taken care by some backend process team. Okay, so this is all just to ensure that organization is adhering to the org level policies. So that's why it's always better to have that baking being done in the source account, okay, not in the application owner's account. So once the baking is done, uh, as Orca scan is done. So this Orca, what the Orca scan does is it scans your AMI for any additional vulnerabilities or any deflection from the org level process. So if the scan is fine, if there are no vulnerabilities, then it will proceed for the further deployments. Otherwise, if the vulnerabilities are there, then it will simply terminate your pipeline. At the same time, once the AMI is available, you can copy your AMI, baked AMI from your source account to the destination application owner's account, where you want to launch the applications. And then after this, when you transition to stage deployment, ALB pipeline will run. So at the ALB pipeline stage, your application load balancer will be deployed on AWS. Okay. So it will provision the application load balancer, and then it will read the application load balancer values, ARNs and all, and then it will search for the AMI which has been sent by the source account. Okay, and it will start deploying on the stage environment on the ALB. Okay, when it is deploying on the stage environment, so basically it will first upload your secrets to secrets manager. So now, um, so here ALB provisioning is happening using HashiCorp Terraform, and for secrets pushing to secrets manager, you can utilize HashiCorp Vault. So your application, so the requirement will be like your application code can't store secrets. You can't store your secret values inside your Git repo. So what will you do? So you will store your secrets inside HashiCorp Vault, and you will have Spinnaker to to pick those secrets from HashiCorp Vault and push it to your secrets manager. So at this stage, upload secrets to secrets manager. So Spinnaker is actually reading your secrets from Vault and then pushing it to your secrets manager account in the address account. And then at the deploy stage, um, it is the Terraform is basically launching a new autoscaling group, and then it is launching new launch configuration and launch template and spinning up new servers. One older autoscaling group to newer autoscaling group. So once that cutover is done, so then your secrets in the secrets manager are moved to the current version. So at this stage, it was setting it to pending, and now here it is setting it to the current version. And then you have a management step before you proceed to production. So this is so here you can verify your stage application whether it's been correctly deployed or not. You do the complete health check, and then if everything is fine, you can simply go on the management step and you can simply click on continue, and then it will proceed for the production deployment. Now here, between your secrets manager and the management step, you can have one more stage, like the post deployment testing stage, wherein you can run some of the testing scripts to ensure that your staging environment has been deployed um, perfectly fine. Okay, if the stage is if the tests are successful, then it will proceed further. If the tests are um, if the tests are failed, then it will fail your Spinnaker pipeline. It will not proceed to uh, production. Okay, so if the tests are successful, if you want to proceed for production, you will click on continue, and then it will start provisioning load balancer using Terraform uh, in the source account. Oh, sorry, in the destination account, production destination account. And then it will read the production load balancer parameters, and then it will search for the AMI, uh, the baked AMI from the source account, and then it will start deployment on the production. So when it is deploying the production again here, it will first upload the secrets, production related secrets from Vault to secrets manager, and then it starts deploying the production autoscaling group. So once the new production autoscaling group is live, then it will simply move ahead, and it will promote the secrets manager version to the current one. After this, you can even have one more stage to have a post deployment testing for production, just to confirm whether production is perfectly fine or not, and then take a call of whether you want to roll back or not. So this is one of the way, or one of the Spinnaker pipeline which you can have to provision those immutable infrastructure and adhere to that compliances like FedRAMP and all. Okay, so yeah, so we have achieved so whatever we discussed in the earlier slides, so we have achieved almost all of those in this Spinnaker pipeline. And one more benefit of deploying it in this way is like, in order to have production deployment, you have to mandatorily go through the stage or the lower environment deployments. You can't directly go to prod. So you can have you can have your backend validation scripts in such a way that uh, your team won't be allowed to have a production only pipeline. You will always need to have first a day or stage a lower environment pipeline deployment, and then the production deployment. So this will ensure that whatever version of your application is being deployed in production environment, the same version is first deployed and tested in your lower environment. So there will hardly be any chances where your production environment will be drifted from the stage environment. Yeah. So this helps to keep your all environments in sync as well. So it gets easier for you to detect all those drift and all those or investigate and debug any of the issues. That's it.
Thank you, Darshan.
That was super cool and interesting.
Our next presenter is Satish Payati, who is a Senior Technical Director and CloudOps Studio Leader at Globant.
In this session, Satish will talk about the way Globant's DevOps maturity model can be leveraged to implement DevOps mindset and supporting tools with the ultimate goal of increasing value to the speed of business.
Hi everybody. My name is Satish Payati. I am a technical director and studio leader for CloudOps in Globant. Briefly about me, I have 22 years of experience in IT, leading large-scale application development projects, strategic engagements, in consulting and in global delivery model. Been working in cloud for last 5 years. Worked on large transformation projects for cloud, and currently I'm leading the DevOps CloudOps studio in Globant. So I welcome all of you to this conference where I'm going to talk about the DevOps maturity model. Thanks a lot for taking time to spend time with us, and I hope you'll be able to get some really good insights from this session. The topic that I'm going to talk about is the DevOps maturity model. I'm going to first start with the definition of DevOps. What typically people mean by DevOps. What is that our clients, the industry folks mean by DevOps? What is that they're trying to achieve? Then I'll briefly touch upon what are the different nuances in DevOps. What are the kind of key aspects that we see? And then we will go into the DevOps maturity model that we use in Globant. I'll briefly explain to you the maturity model, what are the different dimensions, what are our maturity levels, and how do we actually go about using this maturity model to drive innovations, drive initiatives with our client engagement, and possibly you could leverage the similar kind of approach on how we do it. So firstly about DevOps, right? So DevOps, it's a pretty broad term. Firstly, we all need to recognize and understand that there is no common definition for DevOps. Different people, different companies define in different way. So one of the definitions that I have put here, one of the perspectives that we have is that DevOps, it could be viewed as a culture, right? It can be used as a culture that enables and seeks to enable very autonomous way of thinking in different teams, different software development teams who are responsible for development of a product or an application. And these teams, when we are talking about, those are the teams that are involved in the entire life cycle of the product, right? From the requirements to development to the production support and enhancements, right? So we could view DevOps as a culture that seeks this autonomous way of thinking to to primarily meet some of the goals, right? So when we say DevOps, broadly we are looking at two goals. First is faster time to market, and second is more reliability or availability of the application, right? So that's really what we tend to aim for whenever we are talking about DevOps. Of course, DevOps also goes hand in hand with agile. There are a number of practices, ceremonies that could be leveraged from the agile world to meet these goals. So agile and DevOps, they go in together to meet these objectives, right? So that's broadly, that's one of the definitions that are available in the market. So brief again, going a little deeper into goal of DevOps, right? It said faster time to market and availability. Some of the other goals are also, improvement in lead times, increasing the deployment frequency, reducing the change failure rates, time to recover service. We also get to the terms like RPO, RTO, BCM, right? Release management, operations. Monitoring, end user monitoring. So a lot of these terms come in, but broadly, these are the set of goals that we are talking about when we look at the DevOps. And one interesting graphic that you can see on the right side is that shows the state of DevOps maturity across the organizations, right? So you could see that not all organizations are at the same level of maturity as per. So this is an excerpt from State of DevOps report in 2021. Could see that 26%, around quarter of the organizations are elite, where they are implementing. They have standardized, quantified, and they are improving. They have implemented the standard DevOps practices, and maybe they are also pushing the boundary in terms of the DevOps technologies and practices. And we also have 40% organizations which have a high maturity level. These numbers might vary, but the key point is that not all programs, not all clients have the same level of maturity, DevOps maturity. And in this context, a maturity model will really help us to take people to take companies, to take organizations, or to take projects which are at a medium level of maturity to maybe elite or low to elite. We'll briefly touch upon the DevOps ecosystem. So these are the standard things that we keep on hearing when we talk about DevOps, right? So there are a number of processes that come together, that are interdependent, that work together and end up in a virtuous cycle that will reap the benefits in terms of DevOps, right? So first thing that we could start with continuous integration. When we talk about continuous integration, we're really talking about building, deploying, and testing more often, minimizing manual testing, maybe bringing in some security tools early in the development life cycle, right? So that we could reduce risk, we could ensure the quality, we can make our software deployable, and gain more confidence in the quality of code, right? So that's one process that is part of this ecosystem. And then we move to continuous delivery deployment, where we try to design, automate, and standardize deployment processes across 3 layers: application, service, and infrastructure. This would really enable us to do more frequent releases into production, right? So whatever practices we do, whatever tools that we use to achieve this goal would probably fall into this bucket. And then we talk about continuous monitoring, where we continuously monitor applications, services, infrastructure, end user monitoring, synthetic monitoring, right? So all of these kind of practices terms would fall into this bucket, right? And then of course, when we are monitoring something, we need to improve, we also need to start measuring things. So defining KPIs, defining technical KPIs, defining business KPIs, defining metrics, indicators, and then start measuring them, incorporating them into tools like New Relic or other monitoring tools, to get one single version of truth, and visualizing all of that form the process, form a part of continuous measurement process. And of course, once you measure, you got to learn and you got to improve. So these processes get kicked in. Continuous learning, where we find new solutions, new ways of doing, to find new opportunities, and then eventually we learn from it, and then we create the plans. We come up with new ideas, new concepts, to see where we could improve. And so that's the continuous improvement process, and that again triggers feedbacks into continuous integration, and this virtuous cycle goes on and on, where we will continue to try to improve the whole DevOps practices, right? So that's really a good way of looking at the whole DevOps ecosystem. There are a number of tools, there are a number of technologies to implement this. We will have a flavor of it later, but overall, we do all of this to get some benefits, right? So the benefits, some of the benefits that we could get from DevOps are, we will have production like lower environments. We can do a better design. We generate better deployable software. We will ensure quality. We could integrate test cases very early to ensure the quality of the products. To help with the quality of products, we reduce the risk. We also with the culture element, right? With the culture element, the process element, we will start having better alignment with multiple stakeholders in the project, and we will have a better visibility, right? So that's the sort of objectives that DevOps try to achieve with the help of such a virtuous cycle. And as I mentioned, there are many tools for DevOps. So if you look at DevOps as a circular path, right? And when it comes to plan, you can see that there are many tools, right? So one commonly used tool is Jira, but that's not really the only tool to use. You could use multiple tools there. In terms of build, you have Git, Kubernetes, Docker, GitHub. So many tools that are widely used today, and interestingly keep on coming, right? Keep upcoming. There are also multiple upcoming technologies in this space. And continuous integration, Jenkins, Sauce Labs. So there are many tools there, right? TeamCity, Circle CI, Travis CI. So these are continuous integration tools that are widely used. And then you have deployment tools for Chef, Puppet, Ansible, and so on. When it comes to monitoring, we have tools like New Relic, Nagios, Splunk, and so on. Right. So the key point is that when we start implementing DevOps practices, when we try to achieve those objectives, there are many tools that come into picture. And depending on the clients, depending on the projects, there could be a different combination of tools that are used. And another aspect of DevOps is also that we tend to work on variety of infrastructures, right? Not every solution is same. We find different infrastructure patterns here. Sometimes we work on data solutions, big data solutions, where we need to implement DevOps practices. We have microservices. We could have contact center solutions, right? There are different varieties. So when we really talk about DevOps, just to summarize, we are looking to achieve that goal, the key goals of faster time to market and improve the NFR of the application or the product, and all of these things come into play when we look at DevOps. And the reason why I touch base this is that when you actually look at an enterprise, these are the kind of things that you would observe when you start looking at your DevOps maturity assessments or trying to chart out plans where you would like to improve things. Okay, so now we will go into the DevOps maturity model. So we have multiple levels of maturity model defined here. This is straight from CMMI level 5 definitions. We have level 1 baseline. That means where the processes and tasks are unrepeatable, poorly controlled, and reactive. Then we have level 2, where it is slightly better than level 1. Of course, the process is documented, maybe partly automated, but highly these levels are reactive in nature, right? And let's say we proceed at a higher level, then we start making our processes consistent. We make it automated through the application lifecycle. We make it consistent, and then once we are able to make consistent, we go to level 4, where we start managing things quantitatively, where we could measure the processes, we could control the process, and then take it to the next level of optimize, level 5 optimize, where we could focus on the process improvements, what we could do, right? So that's the sort of levels that are defined in the maturity model. Now we'll go into the different dimensions of the maturity model. So our maturity model measures the DevOps maturity in multiple dimensions. First is the culture and organization. The next is design and architecture. Third is build management, environment management, deployment and release management, internal process compliance. And the name might say a very small thing, but we know that different industries have different compliance standards, right? So the banking industry might have certain standards, and those standards quite differ than the medical industry or a transportation industry or a marketing organization, right? So we look at the overall compliance in terms of their internal processes. That's one of the areas. The data management, testing, what kind of testing we do, what is the test coverage, etc. And then information analysis and reporting, try to give a visual view of the overall DevOps maturity to the managers, right? And then monitoring and the overall ecosystem. So just to take a pause and recap. So we have the two elements in the maturity model. First is the levels that we have defined, and then the various dimensions with which we would do an assessment. So now we'll go into the maturity metrics. So as with any maturity model, we define different different criteria for each baseline. For each maturity level. So, for example, when we say culture, so if we are looking at a project organization or an organization unit which lacks vision, which has a very restricted communication, they work very much in silos, and they lack organization skills, and they are heavily dependent on experts outside. So probably they are at level 1 in terms of culture. Whereas, right, you could see the progression there. Whereas a level 2 level they would have clear requirements. Security is also considered there. They are much better organized, right? And when it comes to the level 4 managed, they would have frequent and collaborative communication. They share knowledge. Their pods or the agile teams are organized by products. And as they move to level 5, they'll have fast and continuous feedbacks. They have an ownership mindset. Uh, the pods, the agile teams are driven by KPIs. They revise their training programs, and they look at their team's organization continuously. Okay, so when it comes to processes, again, right, at a level 1, it's all highly manual, inconsistent. You never know whether the process would be successful or not, whether it is repeatable or not. And reports, for example, reports are very generated on demand, right? Only when people ask. And security is pretty ad hoc by project. So nobody, probably, the teams are not thinking about security that much. But when you go into, again, level 3, level 4, we're talking about quantitative project management. We start implementing continuous delivery practices. We have consolidated reports for management. And when we take route to the optimized level, we're talking about continuous deployments, continuous improvements, predictive reporting, continuous revisions to the security plans, right? So that's these definitions of the intersection of a dimension and the maturity model is very clearly defined in the maturity model, and that will help you to benchmark the organization in question to see where they are in. So it's a very clearly defined model. Now, we looked at the culture process dimensions. Let's look at some of the technology dimensions. So again, when we look at environment management, if it's a level 1, we are looking at somebody who's doing manually doing the configuration changes very manually. They provision environments manually. Whereas as they proceed from level 2 to level 3 to level 4, the theme of infrastructure as code comes into picture, right? Level 2, they automate some of the configuration changes. Level 3, they also automate environment provisioning. They clear the security baselines, and as we go level 4, level 5, the whole infrastructure is written as code, right? So they'll be able to spin environments on the fly, considering all the aspects, considering even security, considering the organizational standards, overall standards, and the infrastructure is also available, highly available, right? So the dimensions, again, on the technical side, the intersection of dimension and the maturity level is clearly defined for us to benchmark. Similarly, on the CI/CD, right from manual, we would go into CI/CD pipelines as code. So this is just an example that we have put in here. We have much more detailed questionnaire, much more detailed criteria to do that assessment based on our knowledge and expertise from DevOps implementations. Similarly, on the QA, some test automation, unit test, whereas in level 5, we are aiming for very high level of coverage, right, through SonarQube or some other tools. So typically the assessment process would be something like this. Let's say we engage with the client. We would structure it in 3 phases. First is the discovery phase, where we would gather all the information about different aspects, right? We would probably do some workshops with the owners. We would look at some of the shared information, architecture documents, spreadsheets, to understand a bit more about the DevOps implementations, right? DevOps practices that you have. And then we will go into an assessment stage where we would start assessing based on the criteria, based on the maturity model. We assess what is the current maturity level for each of the category. And then we will plan workshops. We'll do workshop with the client stakeholders or the project stakeholders, and define what could be our improvement plan, what could be our next level of maturity that we would like to target. So that's broadly the assessment process. We'll go a little detail into that. So this slide again shows that assessment process in a nice picture. We first start with onboarding. We start explaining what DevOps is. In our experience, most of the times, what we have seen is that a number of clients or the number of stakeholders who would like to implement DevOps or raise the maturity really lack the knowledge of DevOps, right? Sometimes they tend to have very unrealistic expectations. What probably sellers would talk about it, tool sellers would talk about it, or sometimes they're just not aware about the multiple dimensions that are available. So the first stage, the onboarding stage, could be really going through the DevOps maturity model and talking about the different dimensions to look at, different maturity levels to look about, and then talking about the process that we would be following as part of these kind of assessments. And then, of course, the next stage would be assessment, where we'll start doing the assessment. We'll go a little bit detail into it, and then we'll come with an action plan, and then we go into transformation. Transformation is really the execution mode where we will start changing things on the ground. And you could see that this is again a cycle, right? So this is not going to stop until you reach the level 5 maturity. So this continuously goes on. So once we do the transformation, you define what is the next level of maturity, and then you pick it up from there. And this is how it goes on. So we'll go into onboarding. So as I mentioned, right, we start with explaining what DevOps is. We look at what DevOps, what are silos. In the meeting, we do the workshops. We usually recommend having a focal DevOps from the client team or the target project team, where we would like to improve the maturity model. And we work with them to have these workshops and explain the details. And then we go into the assessment stage, where it could all again be broadly looked into 2 parts. One is where we are doing interviews, right? We send some surveys, we set up workshops, we set up meeting with the key stakeholders to understand the current DevOps implementation and also understand the objectives, right? The objectives of the engagement. So that's what happens during the assessment phase. A lot of times, documents carry a certain perspective. Let's say an infrastructure architecture document would really look at infrastructure part, really doesn't talk about the cultural part of the whole organization, right? So the documents that are shared have limited perspective, limited information, and this is where we conduct these workshops, interactions with senior stakeholders to come up with our assessment. And this is the stage where we do the assessment, and we use our DevOps maturity model as the reference model to go through the checklist and arrive at a particular maturity index for a particular dimension. Then we arrive at the action plan. The maturity model that we have really gives a good number of actions based on our experiences, based on the assessments we have done. But the key here really is to adopt a plan that is feasible and that is simple in action, right? So there is no point having a list of actions for 200 actions which cannot be implemented in subsequent sprints, right? So we work with the key stakeholders to come up with an action plan which has short and simple actions that will slowly raise the maturity level of the DevOps. So that's really what happens in the second stage. So this is a sample improvement plan that we worked out for one of the clients. So as you could see, right, we have these levels as a column, level 1, level 2, level 3, level 4, 5, and we have our dimensions as rows, and this is assessment result, right? So this is basically what we have arrived at, right? So let's say when we assessed the client for culture and organization, we found them to be level 2, right? And design and architecture would be at a level 1, whereas the testing is at level 2, and information analysis and reporting is also level 1, right? So this is the current state that we have arrived at. And when we discuss with the client and we decide as a team that we would like to go to the level 4, right? So this gives us an improvement plan. This gives us a roadmap on what to improve, what to implement as we go forward, right? And our tool also gives us recommendations on what is that we need to do to go from level 2 to level 4. For example, they need to, let's case of CI/CD, they need to implement CI/CD as code. Maybe they need to put Jenkins pipeline code in Git repository, do security scans, maybe integrate with security tools, right? So there are a number of recommendations that come from our tool that straight away gives us a action plan. And then we go into the transformation execution stage, right? We call this as a transformation stage because this really transforms the organization, the DevOps maturity in the organization. So we would like to call it as transformation rather than execution. And this is where we believe that a focal DevOps, right? So we have one key stakeholder, from the client side, from the target project team to work with us would really ensure the success of the engagement. So we conduct this transformation, and then yes, so and then this virtuous cycle continues. So once you do a transformation, if we go back to the previous slide, let's say we complete one cycle, when we do an reassessment at the end of the implementation, we might see that, okay, look, we planned for level 2 to level 4, but look, something has happened, something we could not prioritize in the sprint, we ended up at level 3, right? Maybe in design and architecture, we really wanted to go to level 4, but in reality, we ended up at level 2, right? So when we do a reassessment, we get to know where we are again in this table, and we can arrive at the same plan again. So this is how it goes on, right? So this cycle goes on until we reach level 5, right? So this process ideally ends when the pod or the project we call pod, which is an agile team, reaches the level 5, which is an optimized level. So that's briefly about our DevOps maturity model. So just a quick recap. We started with looking at some definitions of DevOps, some nuances of DevOps. What we really mean, what typically clients or organizations mean when we look at DevOps, what kind of goals we look at, and then later we delved into the DevOps maturity model that Globant has. We talked about the different maturity levels and the dimensions we have. We have a pretty comprehensive model in that sense, and we also looked at how this maturity model could be applied to the engagements to drive an action plan, improvement plan, and drive continuous improvements. Okay. So thanks a lot once again for all of you for joining this conference. If you have any Q&A, you could please post it on the chat. Thank you.
Thank you, Satish. Wasn't that a very insightful session, Lovely? So much to cover and yet so smoothly done.
Yes, I liked it very much. I hope many of our audience feel the same. Please let us know your views in the chat window.
Well. Now, let's take our audience to yet another exciting and knowledgeable session. The last session is about GitOps, ChatOps, and GitHub Flow approaches and how, by using these approaches together, can help streamline infrastructure tooling and deployments.
And for this session, our next presenter is Abhimanyu Gupta. He is passionate about setting up cloud native infrastructure, DevSecOps, ChatOps, and AIOps.
Hey, hi all. My name is Abhimanyu Gupta, and welcome to this talk about GitOps, ChatOps, and GitHub Flow. In this talk, I'll talk about these different approaches and how you can combine these approaches to form a well-designed pipeline toolchain. Now, first of all, we'll zoom in into each of these concepts individually, and then we'll see how combined together they make a very powerful solution. So just to give a brief overview of the agenda. So today I'll talk about GitOps. So we'll get into a detail of what GitOps is. Then I'll give you some insights about the ChatOps and how the chatbots can be integrated with our DevOps ecosystem. Then we'll also talk about GitHub Flow workflow and how the different branching strategies within the GitHub Flow workflow can be implemented in this approach. And then I'll talk about the standard implementation. So where all these three concepts can be combined together to make a solution. I'll also talk about the benefits and challenges of this approach. And finally, what are the different enterprise level solutions that you can create and how you can use them as well. So I hope the next 30 minutes proves to be beneficial for you, where you can have some takeaways like you can understand these different concepts of GitOps, ChatOps, and GitHub Flow, and also have the insight about the standard implementation and the use cases. So GitOps, let's try to understand what GitOps is by breaking down its definition. So GitOps is a way of implementing continuous deployment for cloud native applications, which ensures that system's cloud infrastructure is immediately reproducible based on state of a Git repository. So initially, GitOps was actually popularized for cloud-based deployments, especially around your Kubernetes deployments. So in GitOps, normally Git is the main source of truth. So what's happening right now is there is a major shift towards the left where all the configurations are moving towards your Git repository, where it could be your pipeline as a code or your configurations, your manifests, everything is moving as code. So the major problem that is seen is that normally whatever configuration is there in your repository doesn't always match with your environment. So there's a lot of times the sync is not there, which leads to a problem that you cannot actually see your Git repository and definitely say that what's there in the Git is actually there in the repository. So GitOps solves this challenge by creating a sync between these two, your repo and your environment. And in this way, it also makes your configurations, your changes in the Git repository reproducible, where you can reproduce it again and again in different environments just from your Git repository. Now let's try to get a high level understanding of what GitOps is. So from a standard pipeline perspective, you have your application repository where any change happens done by the developer, it triggers a build pipeline. The build pipeline is would be your pipeline which actually does the code build, code compilation, and your packaging, code quality checks, your unit testing, and everything, right? And once that is done, if we are talking about the containerized applications, this pipeline will also push the changes to your image registry. So what it will do is it will create a Docker image and push it into your image registry. Now, this is where your regular CI/CD pipeline is. With a GitOps approach, there's additional step where your build pipeline also updates your environment repository. Now, environment repository is different from your application repository. This is where you are keeping all your configurations. So, for example, in a containerized application, your Kubernetes manifests would be kept in a separate environment repository. Okay. Now, as soon as the build pipeline updates the configuration here, it triggers a deployment pipeline, which ultimately deploys into the environment. Now, how the sync is maintained, how GitOps is a more advanced CI/CD version that we'll look into the future slides. So in order to understand the GitOps concept, first of all, let's try to understand the different CI/CD mechanism that can be used. So there is a push-based deployment and there could be a pull-based deployment. So push-based deployment is mainly used in the application configuration where you have your application code, you make the change, and that change is actually pushed to the environment. Also, if in the GitOps approach, you could be using this push-based mechanism where your configurations are there in your repository. As soon as the configs are changed, your CI system will actually trigger a pipeline, trigger a change where it could be pushed to the environment. But with a push-based deployment, you are seeing it's always a one-way deployment where whatever change is happening in your Git repository is pushed to the environment. And now this push could be a manual push via CI system or it could be automated push. So the challenge here is that whenever the push happens, after the push is done, there's no sync between your repo and your environment. And so, and you know that normally what's happening is your Git repository is always updating. So it's not necessary that whatever changes there in your Git repository is immediately replicated in your environment, and there's always a lag between it. To tackle this, GitOps normally uses a pull-based mechanism. So what happens here is, in the same example, let's say you have a containerized application, right? So in a container-based application, you have, let's say it's running as Kubernetes pods. So in the same cluster itself, you will have your agent running. Now this agent is your GitOps agent. It could be your Argo CD, it could be your Flux CD, or any other GitOps agent that you are running. Now what this agent does is it always pulls from the repository. So this is your actual source code repository. It could be having your Terraform files or Kubernetes manifests or whatever configs you are maintaining. Whatever agent you are using, could be your GitOps agent. It could be your Flux CD or Argo CD, whatever agent you are using. It will always pull all the changes that are happening into your repository. Now this repository is your config repository. It could be your Terraform files or your Kubernetes manifests. So whenever a developer makes a change here, this repository is updated. Your agent is polling this repo, and it will know that change happened, and it will automatically sync that change over here. So your agent is always working to maintain that whatever is the desired state is synced back to your environment. So it is always maintaining that the desired state is equals to your actual state. Another advantage is, let's say it pulled the change from this repository and your cluster is updated with the new config changes. Now, what happens if someone goes into the cluster and manually makes the change to the config? Someone, let's say, goes and updates the number of replica set for your pod, or someone changes the auto scaling metrics manually. Again, your agent will know that something is changed in the environment which is not matching with your repo, and your desired state and actual state are changed. And this way, it will again pull and sync all the changes from here and revert any manual changes that happened here. So this is very powerful because with the push based, always whenever if some manual changes are happening in the environment, there is no sync between your repo and your environment. Now let's try to understand another concept, which is ChatOps. So ChatOps is a model where people, tools, process, and automation are connected and which collaborate and control pipelines in one window. So from the DevOps ecosystem perspective, your people would be your ops team. Your tools could be your DevOps tools, like your Jenkins or your containerized tools, or maybe your infrastructure as code tools, right? Now the process would be the process that you have set. For example, you would have set a release process for deployment of your applications, or you would have set up some approval process for your pull request. So whatever processes you have set for your DevOps ecosystem comes into this process. And automation is the kind of automation you have created for your pipelines. Let's say you would have created webhooks for your configuration. So all those automations that you have done. Now ChatOps brings all these concepts together where you can collaborate and control from a single window. Now single window is your collaboration tool. So any of the ChatOps configuration have four main components. One would be your team. Now it could be a DevOps team, your QA team, your dev team, whatever team it is. Your collaboration tool. Your collaboration tool is the tool that you are using in your organization. It could be Slack, Messenger, Microsoft Teams, HipChat, right? And then you will have one bot. Now that bot could be HuBot, Lita, ERR bot. And finally, your system. Now, from the DevOps perspective, the system would be your DevOps system. It could be your Jenkins, it could be your monitoring system using Grafana, it could be your cloud system, any of the cloud you might be using, Amazon, Google Cloud. It could be your Docker or Ansible system. Now, in this ChatOps concept, your bot is in the central location. Like in your CI/CD system, your orchestration tool is the center, and then it's integrated with different tools. Similarly, in the ChatOps, your bot is at the center. Your bot is integrated with your collaboration tool, and bot is also integrated with your DevOps system. Now, let's say how this can be used is, let's say someone needs to trigger a specific pipeline. So it is as simple as the team member can mention in the Slack, hey bot, can you trigger my automation test suite? Your bot, which is integrated with your system, Jenkins system, will automatically identify the job and trigger it. So now you see this whole thing is encapsulated from the user, and user doesn't have to bother about how Jenkins work, how bot works. The user simply has to uh, type in the chat what action it wants to take, and your bot will do that on his behalf and revert back saying that if the pipeline was triggered, what was the status of the pipeline. So this is one of the multiple examples where you can use ChatOps. Now let's see the chatbot integration with different DevOps tools. For example, you can integrate it with your infrastructure as a code tool using Terraform, or you can integrate it with your monitoring tool, maybe using Grafana and Prometheus. So for example, like let's say with your infrastructure as a code tool, again, your chatbot is in the center. It is integrated with your messaging tool, like Slack, and it is also integrated with your infrastructure as a code tool like Terraform. So now let's say you want to create an infra, right? So you can give simple commands like, hey HuBot, I want to provision a T2 large EC2 instance, maybe in US East region, right? So as soon as you give this command to the bot, your bot will store all the important information into its brain. Now brain is nothing but a database. It could be a Redis or any other memory store that supports your bot, right? And also, let's say the information that is provided by user is not enough, so your bot can ask back. For example, here you didn't give what should be the name of the instance, so your bot will say, can you please tell me the name of the instance? So you have to reply saying that, okay, you can name the instance as test instance. So all this information it will store here, then it will go to the Terraform. Now Terraform will have all your pre-built modules. For example, for creating instance, it will have a pre-built module for AWS because it's a EC2 instance. For example, for your GCP, it will have different module. So all the modules are defined here, and as soon as you give the command, your bot identifies which module to run, and then uses that module to actually create the infra. Once the infra is created, your bot will revert back saying that this particular EC2 instance is up and running for you. So again, you see, your user is completely user doesn't have to bother about the configuration of your bot or how your Terraform is working, right? It has to simply give the commands. And another important aspect is from the security point of view, you do not have to share the credentials of your cloud with your user or with any of the CI system. It is automatically managed within a secure server where your bot is running. Secondly, similarly for monitoring, you can have very targeted monitoring status updates. Like by default, your monitoring tool will keep on giving you all the information. So where your email or your Slack channel would be flooded with a lot of status updates, right? But using bot, you can have a very targeted information. For example, let's say you just want to know the Java heap size, or maybe the HTTP requests happening on one of your payments microservice. So it's as simple as user will go to Slack in where the bot is integrated, and it will ask bot, hey Hubot, what's the current status of my payments microservice? Or it might ask that what's the Java heap size of my current payments microservice. So your bot will go back to the Grafana dashboard, fetch that information, and revert it back in Slack. Now user doesn't need to have access to your Grafana dashboard or Prometheus, even doesn't need to know how this tool works. It has to simply give command to the bot, and bot will perform operations on its behalf. Also, you can schedule your bot to provide you updates on the specific target statuses. Like you want to know every 5 hours that what's the memory usage of my payments application in production. Out of, let's say you are running 50 microservice, you want to know specific to the payments microservice. So you can give those specific, you can configure your bot to have those specific updates at a regular time interval. Now, the third concept is your GitHub Flow. So as we know that with the Git Ops approach, everything is moved to Git. So it is very important to have a well-defined and systematic branching strategy to support the Git Ops approach. With a regular GitHub flow, with a regular Git flow, what happens is you have master branch. From master, you create a develop branch. You have then from develop, you create feature branches where you work on your features. You create a release branch. From release, you deploy into the environment and merge it back to master. Now this is like a very cumbersome because you are managing lot of branches, and this is helpful from the application deployment point of view. But when you talk about the configs, when you are dealing with your manifest or your infrastructure as a code files, then this concept is not very helpful for efficient deployment. So for that, you can use a GitHub Flow workflow. Now, GitHub Flow workflow has a very straightforward system where you have a master branch, right? And whenever you want to update the configs, you create a feature branch from the master branch, make the changes here, create a PR, and merge it back. Now, the important aspect is that always your master branch or your main branch is deployable, which means that as soon as a change happens here, it is ready to be deployed into the environment. Now this puts pressure that whenever this feature is merged, it should be well tested, updated, and approved. So we'll look into the future slides. I'll tell you how you can make it more foolproof, where when the change is merged, you are sure that this change can be deployed into the environment. So this is where your GitHub Flow and your GitOps combine together. So for example, let's say you have your config repository. It could be your Kubernetes manifest, file, Terraform files, or Ansible playbooks. Okay, maintaining into your environment repo or your GitOps repo. Now, your DevOps team member or any of the infra team member updated for example, updated the manifest file. Okay, once the changes are done, for example, that he wants to add a new config map parameter or added a new secret or something, right? And that change is done, and then what this ops team member will do, he will raise a PR. Now once the PR is raised, it will automatically trigger a CI pipeline. Now, in a standard DevOps CI/CD concept, your CI pipeline is something that does a code build, where it does a code compilation, code quality check, unit testing, updating artifacts in Nexus, and so on. However, here we are dealing with the config files, so it's very important. So here we don't have those specific build sort of CI pipeline. Here the important part is to make the checks. So the CI pipeline here, you could be using Jenkins to run the CI pipeline, which will actually, for example, for the Kubernetes manifest, you can use a DA tree tool. So your CI pipeline is nothing but make a check to the manifest and see if all the configurations are properly done. Once it does the check, it updates your PR saying that these are the checks it's done and the checks are passing fine. Also, it will give you information or updates about any suggestions to the quality, or any misconfiguration is there, it will give you suggestions over there. Now, this helps your approvers to make an informed decision whether to approve the PR or not approve the PR based on the success of your CI pipeline. If you have a Terraform file, your CI pipeline will run a Terraform plan saying that this is the list of infra that is going to be created, and your approvers can see if the correct infra is getting created or something needs to be changed. Or maybe for your Ansible playbooks, you can use Ansible check mode run, where it will do a dry run of your Ansible playbooks and make sure that it will actually show you that what all new configuration tools are going to be installed on your, for example, your Jenkins slaves or your servers. Once the changes are approved, they can be merged to the main branch, where your CD pipeline will actually deploy that change into the environment. Your CD pipeline could be your Flux CD, or could be using Flux CD or Argo CD or Jenkins X based on the tool that you're using. So now let's see the standard implementation. So we saw how GitOps concept works individually, how ChatOps works, and how GitHub Flow approach can be used. Now let's see how combined together they can provide a very powerful solution, and more importantly, how you can actually use it in a production environment. So this is the standard GitOps approach, where, as I said, a developer will make a code commit into the application code. Now the application code is updated, which in turn triggers the CI pipeline or your CI/CD pipeline. Now the CI/CD pipeline will do all the regular build stuff, code compilation, checks, and everything. Create a Docker image, update it into your Docker registry or any of the image registry. Also, in turn, it will update your GitOps repository. Now, GitOps repository, as I said, was your config repository. And once the changes happens into this repo, you have your agent running. Your agent will detect that something changed in this repo. It will automatically sync that change into the environment so that your desired state and your actual state matches, right? So this is the standard GitOps approach. Now, first of all, as we discussed, it's very important that when the updates are happening here, you are following a proper branching strategy. For that, here we can integrate your GitHub Flow, like we said, because now we have shifted heavily on the left side, on the Git side. So you will see lot of PRs which are being raised, right, on the config side. So a efficient branching strategy helps to manage those PRs, and also to quickly deploy. If you have a lot of branching here, then it will be very difficult to deploy, because then it has to go pass on through different branches to be promoted. So here GitHub Flow is very efficient and very effective to be used. Now the second part is, because we have shifted heavily on the left side, so we will have lot of PRs. Now with PRs, you see, it could be as much as like you could have like 30 or 40 PRs every day, because there are small changes which are getting deployed. So here your ChatOps concepts come into picture, where your bot and your Slack can be integrated with this whole approach. And what your bot will do is, it will keep a track of how many PRs are being created. So as soon as a PR is created in your config repo, a notification goes to the approvers into a Slack channel saying that this is a new PR is raised from this repo. And over there, they give the link as well, that what is the PR detail. Your approvers can directly click from there, go to the PR, check, and approve it. Now this is again simplified using your ChatOps approach. Another problem is, let's say your PR is approved, okay, and all the CI checks, as we discussed previously, are also done. Now someone has to go and merge those PRs. A lot of times in the project, it's seen that PRs are approved but not merged. Now what it leads to is merge conflict, because if you have multiple PRs which are approved but not merged, and a later stage PR is approved and merged, then it creates conflict for the previous PRs. So again, your bot can come into picture. So bot will keep a track of every PR, and whenever your PR is approved, all the CI checks are done, it will go ahead and automatically merge it. So now again, a lot of overhead is removed from the dev and ops team, where they have to keep a track of the PR and then go ahead and merge it manually. So your bot can merge it, you, and also inform your approvers when to approve it. Another important aspect where your ChatOps can come into picture for your GitOps is with your monitoring. So as I said, you can have very targeted smart monitoring for your environment. So for example, you are using Datadog for your containerized application, your Kubernetes cluster monitoring. So probably you can be using Datadog for your cluster monitoring as well as for your pod monitoring, or all the application which is running as pods within your cluster. So again, you can have very targeted notifications in your Slack, where you will get updates about what is the status health check of your cluster, also the health check and the status of the pods that are running into the cluster. And anytime if you want a specific information, simply in the Slack you can say that what's the status of this particular application, or what's the maybe the HTTP requests coming to, how many HTTP requests are coming per minute to this particular application, and you will directly get all the information back to your Slack. Another important aspect is what happens normally is in a production environment. In some teams, you do not directly deploy into the environment. You want some kind of control where a change happens into the repository is not directly deployed. For example, in projects, let's say in your UAT environment, some testing is going on for the previous image tag. Now you do not want to direct, as soon as the Git repo is updated, you do not want to deploy it into the environment, otherwise it will affect your UAT testing, right? So you can have some sort of control over this GitOps pipeline, which is not the out of box feature, using your ChatOps approach. So what chatbot will do is, whenever a change happens into this repo, your GitOps agent updates the bot in updates in the Slack channel via bot that a newer image is available. For example, let's say a new image tag 1.1 is available for that UAT environment. Earlier it was running 1.0. So your your QA team Slack channel will get an update that 1.1 image tag is ready to be deployed. Now QA knows when the testing is completed. So once the UAT testing is completed, right there from the Slack, they can tell the bot to actually deploy this new version. Now, as soon as in the Slack they say, okay, good to go to deploy this 1.1 version, your bot will trigger your Argo CD pipeline and it will actually do the deployment into the UAT cluster. Now here there could be a problem with the sync, because right now with the standard process, you have to always keep a sync here. But this is a workaround in case your organization needs specific control or specific control, or want to control when the deployment is happening into the environment. Now let's see the benefits of this approach. So biggest benefit is the automatization, where as you see there is a two-way sync between your repo and your environment. So always your repo and your environment is in sync, and if any change done manually, it overrides those changes and reverts and rejects all the manual changes automatically. Second is idempotence, because whatever is there in your Git repo is always deployable. So you can have the same environments multiple places, or you can replicate that environment at multiple times, because you are very much sure that whatever is there in the Git repo is running in your environment. So it gives you a lot of flexibility and idempotence, where you can create multiple environments. Smart monitoring, of course, as we discussed previously, you can have very targeted monitorings and automated updates by bot. As we see that your bot is automatically merging the PR, your bot is informing about your status of your pods, bot is informing the approvers to approve the PR. So all these automated updates actually makes your pipeline more efficient. And another big aspect of big aspect is your security. So you see right now with this approach, if I go back, as I said, this whole thing is encapsulated from the user. So you do not have to actually share any credentials or anything on your actual CI pipeline, which makes it very secure. And of course, because of all these automated process, your productivity is increased and you can actually deploy very quickly. Also with the GitHub Flow, you do not have to manage a lot of multiple repository or multiple branches for that. So it again saves you from the complexity of managing different branches and creates a process a lot more streamlined and faster. So any solution comes with its own challenges as well. For example, in this approach, we have introduced a new bot, right? So your bot is a central system which is integrated with your DevOps system and your Slack. So there's an added overhead of maintaining the bot, right? Because you have, first is the cost, because you will be running a separate server where a bot is running. Again, then if your bot fails, you need to have some extra effort to understand where the error is coming, and you have to resolve that. So maintenance of your bot is one of the challenge that you can face. Auditing. So now if you see, everything is moved to Git. So if you want to know how many times a particular configuration is deployed into the environment, you will have to actually go through the different commits in Git, which is again a very cumbersome task because you will have so many commits. So in order to search, searching in the Git commits is again not very a very easy process to do. Proliferation of Git repositories. Of course, like for example, in our project, we have like 60 microservices, right? So what happens is, when you have so many repositories to manage, for example, we have 60 repositories for the application code, and then 60 repositories to manage the configuration. So now if you see, there are around 120 repositories that we are managing. So, and every repository also, you have to configure your webhooks, you have to configure your approval mechanism and everything. So managing so many repositories together again becomes a tedious task, because we have shifted heavily on the left side. Okay, issue with traditional workflows. Now there could be some organizations or some projects where which follow a very strict approval mechanism. For example, a banking application would need a multiple approval before before your code is deployed or your config is deployed. Now GitOps approach becomes challenging in this case, because if you want to add lot of approvals in place, so again it's a challenge if you are following a very traditional process of deploying the application, because with GitOps approach is majorly focusing on efficiently and quickly deploying your configuration to the environment, where there are keeping the approval and stops minimum. Of course, the secret management is another problem, because your chatbot as well as your GitOps system doesn't have out of box secret management. Like, it doesn't provide you out of box integration with your Vault or with your Google secret management, right? And also lack of input validation. So as I said, there could be some checks that you are doing before merging the PR, right? However, for example, like you are managing pipeline as a code for your Jenkins. Now there's no check available for to or you cannot implement a lot of checks to check what configurations or what pipeline or what configuration you have done in your Jenkins file. So only after merging you will know, when you run the seed job, that okay, actually some error is coming. So sometimes when you are heavily dependent on Git, so you do not have lot of input validation, and because of the GitOps approach, your configurations are directly getting deployed, right? So sometimes it creates problem if you do not have a proper check of what's being deployed. So what's next? Now, in our previous examples, when we are talking about this approach, we saw majorly on the Kubernetes or containerized application deployments, where how this GitOps, ChatOps, and GitHub Flow approach help you in efficiently deploying your container applications. However, this same approach can be extended further to any of the tool. Okay, now any of the infrastructure as a code tool, as long as your configurations are in the form of code, it can be managed with the GitOps. So for example, your Terraform code, right? So again, a very big problem happens is where your Terraform, you are managing your infra using Terraform, and you created that infra into the environment using Terraform. However, someone from the team went ahead and actually updated that infra manually into the environment, into your cloud system. So again, there is a problem of sync. You thought that this is the infra which was created. However, it is not in sync with over there. For example, the bucket name. Someone went ahead and updated or renamed the bucket name. So your GitOps, so this complete approach helps you to keep that in sync. And if any manual change happen onto the environment or your cloud infra, it will be automatically revert that change. Same for your pipeline as a code. Let's say you are keeping all your pipelines at one place, right? In the form of Jenkins file or job DSLs. But someone manually went into your Jenkins dashboard, click on configure and updated those configurations. Again, there's a lack of sync. So you can use this approach to actually keep it in sync, where your GitOps will keep a track of all the syncs. Yeah, so if you want to manage the Ansible playbooks, you can also use it, where you can actually sync your environment with your what all tools you want to install. It will always be synced with your server or your slaves, where you want to configure those tools. Thanks a lot. That was pretty much it from my side. I hope this talk proves to be helpful for you to understand all the different GitOps, ChatOps, and GitHub Flow approach. Thank you.
Thank you, Abhimanyu. That was an amazing participation from all of you. Wonderful to interact with you all, even when it's virtual.
We had 2 amazing days full of interesting sessions. Hopefully, you guys enjoyed this as much as we did. We look forward to seeing you at our CloudNXT conference next year.
Thank you to the wonderful audience. This was an amazing time with you. We are looking forward to a further insightful CloudNext conference. Thank you, everyone.
Thank you.